So when we're factoring trinomials, as we just said, all we need to do is be able to find two numbers that add to the middle here, and those same two numbers that multiply here. So given that we are looking at x squared plus bx plus c, how we can say this is we simply want to find two numbers that add to b and the same two numbers that multiply to c. Right? So call these numbers out again, we just came up with them. 3 and 4. So then one other piece that we need to mention here is that when we're factoring trinomials, so when factoring trinomials, the answer is two binomials. Right? Factoring means undo multiplication. So in this case, we are undoing FOIL, and when we use FOIL, it only works with two binomials. So the answer here, you guys came up with the numbers, it's going to be x plus 3 times x plus 4. Or the other way around, x plus 4 times x plus 3. Order doesn't matter in a multiplication problem. So that's it. Right, that's all we got to do. We just need to think of two numbers that add to the middle and multiply to the end. It's a really nice way to factor. Now, I think it's also nice to know where this comes from. So this is the how you factor. If you're curious about the why this works, you can jot this down. If you don't care, then just kind of follow along. So the why this works. Let's say that we took these two binomials. So instead of having 3 and 4, we picked letters that are just any integer we want them to be. So let's have x plus m and x plus n, right? N and m are just any integers, right? Integers could be positive, they could be negative, they could be 0, but as a fraction, they're always divided by 1. And let's FOIL this and see what happens. So if we use FOIL, this becomes x squared plus nx plus mx plus m times n. Right? This is what happens when we FOIL. Now we can't do anything with this. We can't combine like terms only because we don't know what n and m are, although these are like terms. But one thing that we could do to make this easier to read is we could rewrite it as x squared plus, and since they both have an x, right, and n and m are simply, they're just numbers, like they're like 3 and 4, or any number we want them to be, we could, this is going to become m plus n in parentheses x plus m times n. So really what we have is this is your b, and that's your c. So this is where the two numbers that add to the middle and the same two numbers that multiply to the end, if you use FOIL in something like this, this is where it comes from, right? So this is the why it works. We have something like this.
X minus 2, close bracket, and then x minus 4.
All right, these two numbers add to a negative 6 and multiply to 8. Lily, next one.
X plus 8 times x plus 10.
All right. Porter.
X plus 4 times x plus 10.
Do you want to change your signs, Porter?
X minus 1 plus times x minus 10.
There we go. Add to a negative, multiply to a positive. Tyler, next one.
X plus 7 parentheses x plus 8.
All right. Denise?
X plus 6 times x plus 9.
These two add to 15, multiply to 54. Alex, last one.
X minus 5 times x minus 5.
Add to a negative 7 and multiply to a positive 10. Awesome. People we haven't heard from yet today. Ellie, didn't we already talk to you? Maybe not. Go ahead.
Okay. For the first one,
Yes.
x plus 8 and then x minus 3.
All right. Good.
X minus 10 times x.
All right. How about 1? There we go. Felix.
X minus 5, x plus 10.
John.
X plus 8, x minus 5.
Stuart.
X plus minus
7 times, and then x plus 1.
And lastly, almost everybody. Go ahead, Hannah.
X minus 9, x plus 4.
All right. Starting with part A here, who can take out the GCF and tell us what is left over, right?
The GCF is x, and what's left over is x squared plus 7x plus 12.
All right, now, somebody else finish the problem, Sam?
You get x times x plus 5 times x plus 2.
Those add to 7, they don't multiply to 12, though.
Oh, it would be x plus 2 times x plus 5.
Yes. All right. So we end up right here. So the blue is the answer. All of that needs to be written, the x included. All right, next one, just the GCF and what's left over, Lily.
5 times upon the x squared plus 4x plus 3.
Okay, now somebody else. Miles, answer for us.
5 x plus 3 times x plus 1.
All right, and the blue once again is our whole answer. All right, GCF out of part C. Denise,
2x.
keep going. What's left over?
X plus 2 times x plus 4. X squared plus 6x.
And then somebody factor this for us, Chris.
It'd be 2x times x plus 4 times x plus 2.
All right. Now, how many of you guys think you got part D? I'm just curious. Show of hands. Okay, so let's do a step beforehand. How many of you guys can factor this x squared plus 6x plus 5? Somebody factor that for us. Stuart, can you get it?
X plus 5 x plus 1.
That's the answer. This is what we call quadratic like. Hannah, did you raise your hand? Do you want to give us an answer for this one?
I said x squared plus 1 times x squared plus 5.
All right. X squared plus 5. That is the correct answer. So anytime you have your first exponent is double the second exponent, this will work. All right. Anytime first exponent is double the second exponent. So this is the same thing if this were x to the 10th plus 6x to the 5th plus 5. The answer would be almost the same, x to the 5th plus 1 times x to the 5th plus 5. Right? Anytime the first exponent is double the second.